Welcome back, guys. We're going to do some more work with compound inequalities and interval notation. So this is 4.4 part 2, and we're on page 13 in your packet. All right, so just a little practice from the last video. Graph each compound inequality. Remember, if it says and, it has to fit both descriptions. If it says or, it can be one or the other. And a lot of times with or, think about a boat. If you're rowing a boat, the oars are sticking out. A lot of times that happens with or. That will never happen with and because you have to shade in between. All right, so x is less than 7. So think about some numbers that could be less than 7. 6, 5, 4, and so on. For the second part, x is greater than or equal to -2. Well, it could be -2. It could be -1. It could be 0. It could be 4. It could be 5. All right, so basically, we're going to focus on that. So it has to fit both descriptions. So let's start with x is less than 7. So it's an open circle on 7 because it won't actually hit 7. We're going to shade the numbers that are less than 7 until we get to -2. The numbers also have to be greater than or equal to -2. So I like to find my two endpoints first. And then I'm just going to shade in between. Compound inequality. With, I know it's not written on here, but with interval notation, take your two boundaries. So my left-hand boundary is -2. My right-hand boundary is 7. -2, it's equal to it, so we're going to have the brackets, which look like an equal sign connected. And then 7, it never actually touches it, so it's going to be parentheses. All right, for or, x is greater than or equal to 5. So we'll shade the numbers that are greater than or equal to 5. Or it could also be x is less than -1. All right, so your values could be 6, 7, 100, but they could also be -2, -5, -70. All right, it could be one or the other. All right, but with and, it has to fit both descriptions. So you shade in between if it's or. Remember, think of rowing a boat. Here's the boat. There's your oar sticking out. All right, part C and D, a little bit different. It wants to know if these are true. Remember, with and, it has to, both parts have to be true. With or, one or the other needs to be true. So let's, if x equals 1, figure out if it would make this whole thing true. So let's plug it in. 3 times 1 plus 8, we want to see if it's bigger than 9. 3 times 1 plus 8, you can put it in the calculator. You get 11. Is 11 greater than 9? Yep. A little check mark there. Over here, let's see if it works on the other side. -2 times 1 plus 10, we want to see if that's less than 7. That gives us 8. Is 8 less than 7? No. So could that be the solution? No. Both parts are not true. Remember, it has to fit both. Think about that. I'm going to the mall and the park. I need to be going to both places. I went to the mall. I didn't go to the park. I lied, so it's not true. With or, it's different. If one part is true, the whole thing is true. I went to the mall or the park. If either one of those is true, we're good to go. So this time it wants us to check x equals 5. So let's plug it in. 2 times 5 minus 1. We want to see if it's less than 3. This is 10 minus 1, which is 9. 9 is not less than 3. But remember, it's or, so it's not wrong yet. All right, x plus 7, 5 plus 7 divided by 2. If that equals 6, we're good. 5 and 7, that's 12 divided by 2. 6 equals 6, that's right. So remember, Since that's true, the whole thing is true with or, because think about, I'm going to the mall or the park. Well, I went to the park, so since I went to one of those places, it's true. So, yes, at least one part is true. All right, a little bit of review. Not a compound inequality, but it's good to be able to solve these things. So I'm going to draw my line down. Again, if you want to pause the video and try this on your own, not a bad idea. So we'll distribute first. 3x minus 15 plus 3x is less than, bring that less than down. Now, there's nothing in front of these parentheses, so you can just ignore them. 7x plus 45 plus x. If there's nothing in front, it was just there kind of to group things together. There's nothing that needs to be distributed. All right, simplify each side down. I'm going to look for my x's first. 3x plus 3x is 6x minus 15 is less than. 7x plus x would be 8x plus 45. Now, once again, you want to combine your x's. If you want to move the 6x to the other side, since it's smaller, fine. But I prefer, when I'm dealing with inequalities, to move it to the left. I think it just makes it easier at the end. So I'm going to subtract the 8x because it's positive. I'm left with negative 2x minus 15 is less than 45. Add 15. Negative 2x is less than 60. And then right here, I'm going to divide both sides by negative 2, which means we got our rule. X is no longer less than, now x is greater than negative 30. All right, so let's go back up and graph that. Negative 30 will go in the center. As we move to the left, we get smaller, so it's negative 31, negative 29 this way. X is greater than negative 30, so it's an open circle and shading to the right towards the numbers that are greater. Now it says, what's the smallest integer in the solution? Negative 30 is not in the solution. The first integer that we hit that makes that true is negative 29. All right. And the last one, solve the following and graph on a number line. It's a compound inequality. That's okay. This is not ready to graph yet, so we have to solve. We'll just subtract 1. 2x is greater than 14. Divide by 2. We don't have to change anything. So x is greater than 7, or x is less than or equal to 0, one or the other. Well, let's graph them both. On a number line, the 0 would come first. 1, 2, 3, 4, 5, 6, 7 here. 8 would be off this way, negative 1 this way. You could put all the numbers if you want, but let's graph it. If it's or, think about rowing a boat. The or is sticking out the side. So x is greater than 7. Open circle, shade to the right towards the greater numbers, the larger numbers. X is less than or equal to 0. Close circle at 0 because 0 is part of the solution. I'm going to shade the numbers that are less than 0. Negative 1 is one of them. All right, and there's the or sticking out of the boat. All right, so we're going to stop there. The last part of this unit is going to be to finish this practice on the next couple of pages, 14 and 15, and then we'll be set with our unit. So make sure you get the practice in. We'll be talking more about it with some review before your quiz. Have a great day, and don't forget to stop by the math lab with questions.